For the next few moments, I want to discuss what optimization is at a general sense. Then I'm going to walk you through the process on how to perform optimization with Nastran. Uh, for discussion, we're going to work with this very simple optimization example. If you've ever taken a high school level calculus course, you will understand this very simple concept. Now, let's go ahead and show you what I plan on covering. I'm going to show you how to set this up in Nastran Solution 200. What I want to do is show you some fundamental steps that you need to do this in Nastran, like creating a Solution 200 PDF file, creating variables, your objective, and your constraints, executing the optimization, and then looking at the results. These last two items are reserved for actual structural optimization, so these I will not cover in this tutorial. But for 1, 2, and 3, I will definitely cover these in this tutorial. And now let's go ahead and talk about this optimization example. Here we have a curve or a graph, a surface defined by f equals x1 squared plus x2 squared. And then we are going to start off at this initial point 3, 4. So that would be this green point that you see on the screen. What an optimizer will do, and this is what optimization is, the optimizer will seek a minimum on the surface, on this expression f. And this is what optimization is. It's the process of finding a minimum or a maximum for a given function. This example was actually done by Nastran, and I can demonstrate you the steps that you need to perform this example with Nastran, just so you get some information, some experience on how to do this with Nastran Solution 200. So let's go ahead and walk you through the process. In the video description below is a link to 2 files. One of them is a PDF file, and the second one is an Excel file. Let's put the Excel file to the side for now. And let's go ahead and work with the surface dat file. We are going to use the Nastran Solution 200 PDF file to perform or to help us perform this optimization. The web app is going to help us define our design model or the optimization problem statement. This particular example is known as an unconstrained optimization example. The reason is because during the optimization, there is no limit on where the optimizer can look for a minimum. It's free to move as much as it wants until it finds the minimum for this example. So that's known as an unconstrained optimization example. Here on the right is our objective. We want to minimize the expression f that's composed of x1 and x2. It so happens that we want to vary both of these design variables, x1 and x2. So we're going to create these 2 design variables. And now let's go through the process on how to do this for Nastran. Back in the web app, let's go ahead and upload the surface.dat file and then upload it to the web app. Here in the list, look for the property that has theta. And you'll notice that the current value is 3 and 4, the initial values I just discussed a moment ago from the optimization problem statement. Let's go ahead and select theta 1 and theta 2. The theta 1 and theta 2 is not really important. What's important is that the initial value be 3 and 4 for design variable x1 and x2. We also have to create a third design variable, and here I'll look for design variable A for the area, and I'll set this as a third design variable. We need this third design variable as a sort of, a temporary design variable to enable us to perform this optimization. So now let's go ahead and define our objective. We'll click on objective and switch over to synthetic expression. This is where I can type in an expression for the objective. So x1 squared plus x2 squared. And then let's make sure and minimize this. Back in the exporter, let's download both of these 2 new PDF files. And now we are close to performing this optimization example. On my desktop, I have a new folder, 2 optimization directory. I'm going to take these 2 new PDF files and put them in this folder. This is where we are going to perform our optimization. Before going forward, I need to make one edit. So open the design model in a notepad file. And here are these 4 lines. for dvpro 100, 1 million and 1 and 1 million and 2, let's add the dollar symbols to the front. The dollar symbols act as comment lines, so Nastran will ignore these 4 lines. You'll see comment lines whether you're using Python, MATLAB, or other programming languages. So again, the comment lines, when Nastran encounters these, it would just ignore that line entirely. So now let's go ahead and close this and start Nastran. So Nastran will now be used to find the minimum of this graph. We went through the process of defining our objective function and specifying our design variables x1 and x2. Again, design variable x3 is just there to enable Nastran to perform the optimization, and it will be ignored for the rest of the discussion. After the optimization is done, open the F06 file, and let's go to the very bottom of the file. Make sure that you see the message run terminated due to hard convergence. This is indication that the optimization has gone through successfully. Let's scroll up a little and look at this table called Summary of Design Cycle History. This column is reporting the value of the objective function. So here the very starting value is 25, and then at the very end we have something very, very small and basically close to 0. If we look back at the graph, at the initial point, we start off at a value of 25. And if you look carefully, the z value is 25. Here at the optimum, let me zoom in here, we find that the value here is 0, 0. So here the minimum rather is at 0, 0. So again, the objective column is reporting the values of your objective function. And here at the very end of the optimization, the objective function value is close to 0. So now let's go ahead and go back to the F06 file. Here, the design variable history table, this is telling you the change of the design variables throughout the optimization. Remember that we started at the initial value of 3, 4. By the end, we ended at values for x1 and x2 that are close to 0. So we ended at 0, 0. Remember, we are ignoring design variable x3, so you can basically disregard that row. Now let's discuss how to view these same results in Excel. Remember that Excel template? Drag and drop that to your folder where you perform the optimization and open it. Click on Enable Content and click on Create Optimization Plots. This is going to create plots for the objective function and your variables. Remember that the objective started at a value of 25 and ended at a value of 0, so the 0 is the minimum. For the variables, we started at 4 for x2 and 3 for x1. You can see the values change until you hit the values 0 and 0. These values are the same values from your F06 file. So the objective column is reported in this row, and then the design variable values are reported in this section that I just discussed a moment ago. And the other thing I would like to mention is that, again, what optimization is, it's the process of finding a minimum or a maximum for a given objective function. As we saw with Nastran, it went ahead and started at 3, 4, and then it went down the surface until it found the minimum at 0, 0. So this was an introduction to optimization with Nastran Solution 200. In the next few videos, I'm going to show you how to add a constraint. So in the next video, I'm going to walk you through the process of defining a new constraint function. We're going to say that any values outside of the constraint are acceptable values for optimization. And so I believe the video is next on the playlist, so definitely stick around for that. Thank you for watching.